Hi, hello, a warm welcome and peace be with you to everyone. I hope everyone in a pink of health. Before I start, I would like to thank MaTRiX for giving me this opportunity and to my lecturer who believe in me. Before I start, I would like to introduce myself. My name is Daniel Francis from Polytechnic Sultan Mizan Zainal Abidin, and today my presentation is about design and development of kitchen waste biogas digester. As you can see, this is the abstract of this project. I will love to explain it one by one, but due to the time restriction, I would like you to take note on the keywords of this abstract, which is hydrocarbon source, biogas, kitchen waste, biogas digester, and fermentation. So, as we all know, energy is a very important element or important instrument in our daily life. So we can classify energy in two types, which is renewable and non-renewable energy. In non-renewable energy, we can pick up a very important energy that has been using in globalized, which is petroleum and gas. As we know, the supply and the demand of oil consumption is increasing day by day. So if it's continue in this way, there are no more petroleum in the future. Due to the scarcity of the petroleum, we should find an alternative way to stabilize it or to overcome this problem. Biogas is a renewable energy, and we all know that it can be a very great alternative for petroleum. And biogas mainly consists of methane, which is 70%, and it can be a great substitute for fuel and gas cylinder LPG. And we can easily get biogas from organic matter, which is kitchen waste or animal waste. When we say kitchen waste, it's related to our title, anaerobic digestion. So anaerobic digestion is a process when organic matters such as kitchen waste or animal waste that has been broken down by microorganisms in the absence of oxygen and release gases such as methane, carbon dioxide, and etc. Anaerobic digestion is carried out in two ways, which is thermophilic and mesophilic. And anaerobic digestion also can be divided in three steps, which is hydrolysis, acidogenesis, and methanogenesis. The problem statement of this project. Kitchen waste are dumped to landfill and incineration causes environmental pollution, especially air pollution problem. It can be attracting vectors such as rodents, birds, and insects can be affect to the public health. Finally, we require more resources, example, workers and costs, collect the floating kitchen wastes. There are many previous solutions that has been taken in the past that relate to the project. One of them is biodigester in Ukraine. The biogas plant is designed to stimulate production of a clean energy by providing framework for licensed alternative energy such as the Ukraine Milk Company. Another previous solution, biogas chamber of dairy farm at Semenyslangho in our own country. The generator is used to convert the gas into electricity for lighting and vacuum pumps for extracting milk from the cows. Furthermore, there is another previous solution, biogas plant Altmark, Germany. The one of the Germany's largest biomethane refiners has located in the Altmark, Germany and has been supplying to the public grid. Objective of the project. Firstly, to design the kitchen waste biogas digester. Nextly, to fabricate the kitchen waste biogas digester. Finally, to analyze the kitchen waste biogas produced from the biogas digester system. Scope of the project for designing. Literature review on biogas and biogas digester using a design software, Autodesk Inventor, to design the kitchen waste biogas digester. Draw the schematic diagram for the kitchen waste biogas digester using microscope visual. Scope of the project. Fabricate. Firstly, 20-liter capacity plastic tank were used for the biogas digester. Secondly, assemble the collector tray to facilitate the kitchen waste into the waste feeder pipe. Furthermore, assemble 1 meter PVC pipe with 2 inch to the main tank as a waste feeder pipe. Then, assemble the drain valve to the main tank to remove dry solid kitchen waste for the byproduct fertilizer. And finally, 10 kg of kitchen waste including fish meat, rice, and chicken meat used during the analysis. Scope of the project: analyze 10 kg of kitchen waste including fish meat, rice and kitchen meat used during the analysis. Use a digital thermometer to measure the overall temperature and humidity in the main tank. Finally, parameters for the analysis of the functionality are humidity and temperature inside the tank and outside the tank with a duration of 10 days. The methodology: kitchen waste biogas digester flowchart. Studied from literature review on biogas and biogas digester. Follow up with idea generation, conceptual design, design selection, proceed with the design if it's right, detailed design, solid modeling, fabrication process by assemble, painting and etc. Test run, proceed if it's right, data analysis, result and discussion documents, and to the end of the project. So the figure 3 shows label A as orthographic design and label B as exploded view and label C as isometric drawing. So the figure 4 shows the schematic diagram of kitchen waste biogas digester. So it all starts from the collector tray to the inlet valve, waste feeder pipe which enters the tank A. The tank A is the kitchen waste. The kitchen waste is inserted with pressure gauge, digital hydrometer, and the flow continues to the high pressure hose, and the flow goes to the biogas outlet valve and enters the tank B, and the flows continue again to the high pressure hose to the burner. And you can see the complete set of the project in figure 5, the full assembly project. So in figure 6 it shows temperature and humidity graph. After analysis for 10 days by temperature and relative humidity, we can observe that anaerobic digestion process is occurred due to the presence of bacteria when the temperature and humidity are higher. When the temperature is higher, the humidity is higher, that's the perfect time for anaerobic digestion to take place. As for the conclusion, more kitchen waste quantity and higher surrounding temperature produce more biogas throughout productive fermentation. High humidity level in the closed tank show the anaerobic digestion is occurred. The kitchen waste byproduct can be used both as soil, fertilizer and animal feed. Kitchen waste biogas that can be used as a replacement for conventional cooking gas, LPG. And lastly, higher amount of gas is produced with the extension of fermentation process time in the closed tank. So here I enclose my presentation today for Malaysian TVET on research via Exposure 2021, MaTRiX21. Thank you and take care.